Hello, everybody. Thank you for joining today's webinar, JuliaHub Air, JuliaHub for Secure Computing Environments. This webinar will be led by Matt Bauman. He is the Director of Customer Success at JuliaHub, and Luke Amdor, he's the Director of Engineering at JuliaHub. You can ask any questions by raising a hand or typing in your questions at the Q&A section, and we'll answer them as and when that comes in. To start off with, Matt will take over from here, and then Luke will continue further. Over to you, Matt.
Greetings, everyone. Thank you, Sanjeev. Thanks, everyone, for joining us today. I'm really happy to be giving this webinar on JuliaHub Air, our air gap solution for working with Julia in secure computing environments. I'll talk through a number of the key features, the key tentpole things that make up the JuliaHub Air offering. Then I'll hand things over to Luke, where he will walk through what it actually looks like, the nuts and bolts of installing it, the architecture, how you administer the air-gapped installation, how you use it, and then how you get package updates and things like that to the air-gapped network. Lastly, we'll talk a little bit more about security, both beyond the gap, right? An air gap is just one part of a security solution. And then we'll talk a little bit more about what we're working on this year and some of the exciting new features to JuliaHub that are particularly relevant for the air-gapped environment. So those of you who are here probably already know that there's a divide in many organizations between scientists and developers. This was really nicely expressed by Matthias Cox, talking about the two culture problem. Beyond just two languages, there are two cultures, a culture of the scientists working to prototype and develop and do the work of research and development, and then the developers who want to deploy that. They want high quality code. They want to work with best practices and figure out exactly how to best express this in a performant way. And that's where Julia excels, right? Is bringing these two cultures together into one language, one way of expressing your problems that both developers and scientists can collaborate on to easily bring ideas into production. Of course, this picture changes if you want to securely bring your ideas into production, right? Then in many organizations and environments, you end up behind an air gap where Julia can no longer reach out and access the kinds of infrastructure that it uses on a day-to-day basis, right? The package ecosystem, the documentation that you need, and there are also third-party packages where you have the need to access binaries and things like that that we express through artifacts in the Julia ecosystem. And so JuliaHub crosses that gap, brings everything together behind your firewall, gives you the ability to access these things. And so that's why we're here today, to talk about that. The tools that you need in order to do this, right? The kind of the key features that JuliaHub has encompasses these 5 tentpole columns, these five aspects. We have the package ecosystem and the artifact ecosystem from the open source world, right? You need to be able to bring the ecosystem into your environment, know exactly what you're bringing into the environment, and have support not just for Julia and Julia code, but also the third-party binary artifacts that come from other languages. Julia stands atop a great community beyond just the Julia community, where many packages from plotting to GPU compute and many things in between require DLLs and shared libraries and things like that in order to function. There are then private registries that you can build and encapsulate into your environment where you develop your own inner source ecosystem. The packages that you and your team are developing need to be able to be deployed out both to other users, to continuous integration tooling and beyond. So the ability to connect in a registry with first-class support for on-prem GitLab, Bitbucket, or GitHub, as well as other, bare Git servers. Allows you to, know exactly where your code is, and JuliaHub then becomes the source of truth for the entire ecosystem, both inner source and open source. The documentation that you need in order to code against these things, right? It can be a challenging environment to do your development if you don't have access to the documentation. JuliaHub builds that both for the open source and proprietary registries that you have. There's analytics, traceability, and auditing built into the platform where you can track package usage, see what are the key packages that your organization depends upon to help support and build out your community. And lastly, but of course not least, are the security controls that JuliaHub Air brings to the table, both infrastructurally as well as architecturally, and from our side organizationally, with a secure software lifecycle development that allows you to trust in what we're doing. So let's dig into these a little bit, right? There's the Julia package ecosystem with over 10,000 packages, all within the open source ecosystem. Most of those, the vast majority, are written in Julia, but there's first class support for those binaries through the artifact system, right? If there are shared libraries that need to be built separately, those are traced through artifacts. Notable ones there, include the plotting libraries like GR, CUDA, even MKL, other things like that are provided through the artifact system. JuliaHub Air allows you to define exactly what comes across that gap, which is very important, where you can curate your ecosystem. And there are three kind of key things that get walked back and forth, and you need to know exactly what those are to have confidence in what you're doing in the air-gapped network. First and most fundamentally, there's what's called the air-gap bundle. That defines the software itself, the architecture of JuliaHub. It uses the offline package bundle that you download, and you can curate exactly what packages are going to be available within that gap. So you can choose, for example, a particular subset of the ecosystem, SciML and all of its dependencies, or a tailor-made set of dependencies and all of their second and third and fourth order dependencies and such, and inspect exactly what's going on into, what's being walked across the air gap. And lastly, but also very important, is the debug bundle, right? When you're inside an air-gapped network, if anything happens, or you want some technical support from our teams, we can't get in there very, very appropriately. But the platform has support for a debug bundle that you can extract out, walk back, and explicitly send to us. There's no automatic metrics. There's nothing automatically getting sent back to us, right? It is a truly air-gapped solution, but we have that escape hatch to help your teams deploy, and it's often very helpful at if anything unexpected comes up during the initial installation. When it comes to the package manager and private registries, this looks and feels a lot as though you were using JuliaHub or even just the open source ecosystem itself, right? It brings in all of the packages with the exact versions. You can establish your own private registries within JuliaHub. JuliaHub brings UIs in order to register and update the packages that you have versioned and exposed out through the JuliaHub package server, and has all of those sorts of package management tools built into it for the automatically generated documentation, the searchability across the entire code base that's available to you. So that's, everything in that offline PKG bundle that was walked across, as well as all of the tools that are connected through your private registries and the connection to the on-prem Git host that you use. And JuliaHub automatically builds, deploys, and exposes the UI that you're used to looking at juliahub.com today as a searchable interface for all of the code that's available to you, even behind the air gap. Package analytics allow you to see, exactly who is using the packages, what packages they're using, the key packages within your organization, and then traceability as well, which can be crucially important in cases that a vulnerability is found and you need to look and see, hey, which users installed this package. That auditing is built into the platform. You can see exactly which packages were installed by which users, and keep tabs on the ecosystem and the usage in general, which is really helpful to build that internal community of Julia developers, right? The Julia community and ecosystem within your organization. So with that, I want to hand things off to Luke Andor, who will give a deeper dive into the architecture and how exactly an installation and management of JuliaHub Air looks.
Hi, everybody. Yeah, so I'm going to talk first about the architecture and how what kind of landing zones you have, and then we'll kind of go step by step through those, how the installation actually occurs and how do you get packages into it, administer it, and yeah, it'll be fun. So first, of course, we have our air gap network, right? And we will have workstations that are within that air gap. But first, we got to talk about what is the landing zone for our JuliaHub installation. So we have two different options that we'll talk about today. There's one we call the embedded Kubernetes cluster, which is just basically machines that you have. It could definitely be only a single machine, which is for most cases for just a single package server is more than enough. Or you may already have your own Kubernetes cluster that you're running. And if you do, we can deploy directly into that. It makes management of JuliaHub itself quite a bit easier, if that's what you're used to. Within that Kubernetes cluster is the package server, basically. And it is multiple containers. They all run there. And that is exposed out via just plain HTTP and HTTPS. It's fully dependent on how you configure it. And then on your workstations that are within the air gap, the browsers can connect to that port. All Julia sessions, all Julia REPLs can get then configured to talk to it as well. Authorization, we typically configure JuliaHub so that it actually uses whatever you already currently have for your identity provider. It could be Okta, it could be Azure AD. There's quite a bit different types of OpenID connectors that we can support right out of the box. So that's all the authorization is handled through that. And of course, I mean, the package server itself isn't really useful without packages. So what Matt mentioned before, we have the Julia offline package update bundle. This is something customizable and tailor-made for your specific installation, but it is all the packages, all the artifacts that the packages are dependent on, all generated documentation for all of that. That is all something that you would then upload into the air gap network. And then the package server will then ingest that is what we call it, and make it available to all of the users. And of course, you have to have some way of actually administering, installing things into this, into the air gap network, into the Kubernetes cluster. So we actually use something called the Replicated platform. And for an air gap, you have the air gap bundle, which is all the application itself. And colloquially, they call this the COTS admin within Replicated. And that gets uploaded into the COTS admin, and then you'll configure it a little bit further past that. It'll take all the Docker images that we would have in that, if you're familiar with what Docker is, and will either push those to its internal registry, or they can actually be pushed outside of the actual Kubernetes cluster to your own image registry. JuliaHub itself, we use Postgres for all package information, all metadata, more or less. And we also rely on basic disk for storage of the actual documentation and packages and artifacts. So we'll kind of get into that a little bit. So like I mentioned, there's two different types of landing zones, and these are the two options. We call it the machine installation, also called the embedded cluster, or the existing Kubernetes cluster. For the machine installation, like generally, we have to install into a Linux host. We support quite a few different operating systems or distributions out of the box. Red Hat Linux, CentOS, Ubuntu, Amazon Linux, Oracle Linux. Basically, all Debian based and all Red Hat Fedora based distributions are supported. We do require 8 CPUs, 16 gigabytes of RAM, and we do require a 2 terabyte disk because by default, that's really dependent on the package update bundle. But a lot of these different artifacts, we have to support so many different versions and so many different platforms. So it does take quite a bit. For an existing Kubernetes cluster, I mean, we support Kubernetes versions 1.26 and above. So that puts our support probably within the last 2-3 years of Kubernetes. We do require some specifics about the persistent volumes that the Kubernetes cluster has. We do require access to like a read-write mini, but we can also use NFS, or if you're with an AWS Elastic File System. We also support Azure files if you're running within Azure. And then we need just the basic read-write ones as well, if you're going to use the actual built-in Postgres that we have. All different service types, Kubernetes service types are supported, load balancers, node ports, but we also do support ingress types. So if you aren't familiar with many of those terms, you don't need to be. If you have somebody in your organization that already knows Kubernetes, they're probably very familiar with all of those. So other possible types of considerations that we typically run across when we're doing on-premise installs, we ourselves can host Postgres, like as part of the actual JuliaHub installation, like an embedded in Postgres, but we also can do an external Postgres. So if you already have your own PostgreSQL team, your own database administration team, and they manage Postgres, JuliaHub can easily be configured to use that, and you can handle all your backups and DR through that as well. Other things that we kind of run across are TLS certificates and DNS records, making sure that customers understand the requirements that we have for that. They're pretty simple there. Another consideration is image registries. If you would like to scan the Docker images before you actually deploy them out into the cluster, it's possible to do that. And that requires you to have your own image registry, such as Artifactory, or there's a few others that Docker registry is actually standard, so we support pretty much all of them out of the box. And another thing we do support, if you are not like fully in air gap, but you're in a restricted network where you do have some outbound, but it has to all pass through an HTTP proxy, JuliaHub has ability to be configured for that and use that. And there are some other types of considerations. We have a pretty well-defined Air installation guide that goes through all of these different types of requirements and prerequisites, and goes through all the different types of installation paths pretty specifically. So the actual installation steps are really pretty much basic. So I'm going to be going through them, and you're going to be like, "Oh, is that it?" And that's great. That's what we really want. So it's really 4 steps. Step 1, if you're starting from like the machine installation, you have to do the embedded cluster installation, and it's very easy. Start the JuliaHub installation, which can push up the Docker images, and then get COTS admin into a state where it's ready to deploy. And that leads to step 3, which is configuring that JuliaHub installation with some specific options, and then it deploys out. And then step 4 is getting those packages ingested into JuliaHub itself. Step 1, basically you will get a tar GZ or tarball file which is the cluster embedded cluster installer. It's about 3 gigabytes, and it has quite a few different types of operating. It's that large because of all the different types of operating systems that it has to support, and how different types of package installations it has for those. But you basically use SAP. You could use a lot of different tools to get that up on the machine. It just as long as it gets there, and then you're going to expand that tarball and basically run this install script through Bash with the air gap option, and it'll, after about 5 minutes, it'll fully run through, and you'll see installation complete, and everything will be great. And with the biggest detail out of this whole thing to get is this COTS admin URL. And what COTS admin is the interface to upload the air gap bundle and to configure JuliaHub. So basically, to start it, you're going to upload that air gap bundle, which can then push the images into your image registry. That can actually be done before all of this as well too, but it's very simple. It's go into that URL, say, okay, here's my license file, here's the air gap bundle, and it just works through all the rest of it. And at the end of that, you'll get pretty simple configuration, like what is the host name for this installation, any types of certificate information that you might have, any HTTP ports, any, like, for very basic things. This is just the requirements just to get JuliaHub installed. And after it's all been configured, COTS admin then does what we call pre-flights, just to make sure that, like, this Kubernetes cluster that we're installing to, whether or not it's embedded or it's an existing cluster, like, does it have all the things that we need? Like, we need at least 8 core CPU allocatable. What Kubernetes version are we at? And if that all passes, then it's just a matter of deploying it, and that will kick it off, and you'll see quite a few things deploying. But really, it's getting from the unavailable state to ready state, and then it's up and running. And then you're able to go to the URL that you have configured, and right away you'll see it's pretty empty. There are no packages, but it's up and running. From there, you can configure SSO within the admin. And really, the next step is, of course, getting it so we have the offline package update bundle done or uploaded and ingested. So it's syncing it all the way up. And this update bundle could be very small, could be large. Just that kind of depends on the requirements that you have, what part of that package ecosystem you want. If we're talking the entire JuliaHub ecosystem, it is about 2 terabytes. As a while ago, but I don't think we've checked that recently. But you're going to sync it up, you're going to put it in a specific location, and then it's just clicking a button to kick up a sync. And at the end of all that, you'll see all the Julia packages in there, all 10,000 plus of them, with all the documentation and all the existing metadata about it. So, I mean, and that's really all there is to it. And all the other types of JuliaHub features that you would expect on JuliaHub.com or in your own enterprise installs are all then available. So all the package policies, if you want to restrict things down even further, are all there. So yeah, great. That's it. So back to you, Matt.
Thanks, Luke. I'll just add a few last points here to bring us to the end. And if you think of questions while I'm wrapping us up here, please do type them into the Q&A and we can tackle them at the end. So, of course, an air gap is just the beginning of a security stance that your organization needs. And if you could go to the next slide, Luke, we can see that, this is just one aspect of where we see security and compliance as an organization at large. We care deeply about this. You can find many more details about our security and compliance stance on trust.juliahub.com. But just to kind of summarize some of these things, we look very carefully at our organizational policies with SOC 2 and GDPR compliances, independent auditing, our SDLC, that software development lifecycle, as well as support for virtual audits of our organization at large. And then in terms of JuliaHub Air, it is built atop the shared architecture of our fully featured cloud offering, right? And so, not only do we gain the additional security of an air gap, but we also have robust controls around the application itself, the product itself, because it is deployed in other contexts where security is also extraordinarily important, and we can't rely on an air gap, right? And so the air gap is just an additional layer of consideration atop of all the things that we already do in terms of our network and data and application securities. In particular, right, as an organization, we look at, penetration scans and vulnerability scans of the application itself, and really care deeply about the security here. So the air gap is just the beginning. You can go to the next slide, Luke. Lastly, I want to talk a little bit about a few features that are coming that are particularly important in security conscious organizations. One highly important one are these security scanning and regulatory policies that you can enact as you're building that offline PKG bundle, and bringing them in, so you can choose exactly what open source licenses you're able to bring into your network at a regulatory level, right? There's some institutions may not be okay with certain open source licenses. The vast majority of Julia packages are themselves licensed with the very permissive MIT license, but some aren't. And so for compliance with your regulatory policies, it can be important to make sure that those are enforced at the package manager level. Also coming soon are package security scannings, right? So where you can look through the code of the Julia packages themselves, and perform auditing of that code, ensure that it complies with best practices in terms of security, and manage those policies as well. The other aspect that I'm really excited about is the ability to do high performance computing on-prem within your air-gapped network. So this would be the case where you are installing into an existing Kubernetes cluster that has multiple machines, and hopefully many, many machines, right? So that way you can scale out, and then JuliaHub is able to take advantage of that, bringing the complete feature set of what you see at JuliaHub.com into your air-gapped network, with support for the development environments and the project collaboration tools and job reproducibility, all of that at your fingertips within your air-gapped network. So that way you don't need to create ad hoc multi-machine things. You can lean on the existing Kubernetes cluster that your infrastructure already supports. So that is JuliaHub Air. The key aspect is we're looking to bring all the tools that you need to use for Julia across the gap. And we've talked about how that applies to packages, artifacts, private registries, the documentation and code search tools, the analytics, the security, and then the nuts and bolts of what this application looks like. So if any of this seems interest to you, please do contact us at sales@juliahub.com, or continue the conversation with us. Always happy to talk about how we can help grow the footprint of Julia, both in the open and in the closed, right, and behind these air-gapped networks. So thank you all for being a part of this. We can take questions here. I see one. How easily can JuliaHub Air be integrated with existing HPC systems or private cloud solutions like AWS GovCloud? Luke, would you want to take that one?
Yeah, it definitely can be installed into GovCloud using exactly what we've shown you here, because while we were saying it on-prem, the same type of package installer can be set up in any cloud as well too. We actually have customers that do that within AWS, and have had no issues. There are some things like if you were going to install the GovCloud, you could use EKS, for instance, instead of doing the embedded installer. So yeah, it's definitely possible.
Thanks. Another question, how do you patch releases of Julia? And do we follow a release cycle for all the packages on JuliaHub Air Gapped? So on the first part of that, we don't ship a patched version of Julia. We use the official release, and we embed that directly into the air-gapped solution, so that way you're able to download the latest version of Julia that was in the air-gapped bundle that you walked across into the air-gapped network. And then in terms of the release cycles, that is kind of dependent upon the infrastructure and the policies that you set up. So yeah, if you're in a true air-gapped network where you need to walk something in, download that offline PKG update bundle and walk it across, well, the update cycle will be how frequently you want to do that do that sneaker netting across the air gap and bringing in those packages, and that's a cadence that would be set by your team and the resources that are available. And then kind of related to that, there's a question, will there be one version for JuliaHub Air, or will we have to trace and get all the verified various versions of all packages in the install? So I think that question is regarding the offline PKG update bundle, right? The bundle of all the packages. And that's something that, we have build scripts to help define that, figure out what that is. And we can work with your team to determine, do you want the entire ecosystem, or do you just want a small slice of it that you can more closely audit and control? And that includes versioning information. Is that correct, Luke?
Yeah, it does. If you want
yeah.
specific version ranges or only latest, both can happen. So no problem.
Great. Yeah, these are great questions. Hopefully that answered all of those. We can wait just a second longer here. I think that will do it. Thank you all for your attention today and the great questions. Please don't hesitate to contact us if you have anything further or want to talk about a particular situation with your team. Always happy to have those discussions. So thank you all.
Thank you, guys.
Record version of this webinar will be made available to you through an email, and it will also be available on our website in case you want to view it later. And yeah, thank you, everybody. Thank you, Luke. Thank you, Matt, for the wonderful session. Have a great day, everybody. Thank you.
Thanks.